Hey guys, Pankaj here. Welcome back. In today's video, I'm going to talk about what is the symmetric distribution, what is skewness, and what is kurtosis. Okay, so we have talked enough about normal distribution, right? What if data is not normally distributed? How your curve will look like? Okay, that's what I'm going to show today. So let me share my screen. Okay, I'll directly jump to the whiteboard. Okay. So as you have seen in the previous video, right, we talked about we discussed multiple times about normal distribution, right? So how exactly that normal distribution look like? Let me just draw the curve here. So it will exactly follow the bell curve, right? So what that bell curve has here, mean will be your 0 and standard deviation will be 1, correct? So this is your mu equal to 1, this is your mu equal to 2. Let me just remove this, and here mu equal to 3. Similarly, you will have -1, you will have -2 and -3. Okay, so if you see, if you notice in this graph, right, what exactly it does, or basically this mu equal to 0, wherever it is located, right, it is dividing the whole graph or whole chart into two symmetric part, right? So one part is this, another part is this one, correct? So if you see here, exactly 50% of data is exactly lying in the left side of the curve, and 50% of data is lying in the right side of the curve. That's what is about the symmetric. If your data is symmetrically distributed, and this is what or this is how your bell curve will look like. Okay. What if, let's say, your data is not symmetrically distributed, or it is not at all distributed where symmetricity will be maintained? So how your curve will look like? Okay, so how the curve will look like, let me just show here. I'll take another color. So I'm just going to draw first normal distribution curve, where your mean is here. So in normal distribution, there's one more thing here, right? So all those mean, median, and mode all are lying under this particular point. Okay, that is was the property of Gaussian normal distribution. And now let's take another curve where we are seeing curve like this. Okay, and another curve where that will look like this. Okay. So what is happening here? This is the line of symmetry. If you draw the line further and just draw your asymmetric data, right, you see it is not at all exactly dividing into symmetric part, right? So this is your Bell or Gaussian normal distribution curve, where 50% of data lies here and 50% of data lies here, right? But what about this case? This is not at all symmetric, right? So in this case, what is happening? So in the bell curve, left side of this mean is called negative, and this is called positive distribution. Okay, so basically two part it is divided. So if you see in the next curve where positive side, it is not at all symmetric. Basically your symmetric is somewhere here, right? But it has, see, it has tailed a little more in the right side. Your tail is bigger on the right side, and this is called positive skewed data or right tailed, because in the right side the tail is little bigger, right? So right tail data. So right, we can say right skewed also. Some people say right skewed, right tailed, or positive skew data. Okay, so that is about this. Now you will notice one more thing. So your mean, median, mode all are lying in the center point in the Gaussian normal distribution, right? But what about this positive skew data? What happened to mean, what happened to mode, and what happened to median? Okay, so as usual, this will be your mode in case of your data is skewed, and wherever you see, right, this symmetric, this is your median, and in between whatever it comes, and that is nothing but your mean. So if you talk about which one is better, which one is bigger than, like how the value are compared here, so you will see um, median is a little more positive side, right? So your, in this case, median will be greater than mean, and mean will be greater than mode. That is the property of right skewed data. Okay, that's what happened in this particular case. Now, if you talk about another case where your tail is exactly extended toward left side, so this is coming in the negative side, right? So this will be called negative tailed or negatively skewed or negative skewed data, or it is in the left side, so left skewed data. Okay, this is what you can say. This is right one and this is left one. In this case, what is happening? So your median is coming here, right? So this is your median, and your peak value is nothing but your mode, right? Just draw a mode line here, and in between your mean will come. So which one is bigger here? So your median is always bigger. So let me write the formula, or maybe comparison. Median is bigger than mean, and mean is bigger than, oh sorry, oh, my bad. Let me just remove, because all are in the right side, right? So this particular fall under positive side, correct? So your mode is always bigger than mean, and mean is bigger than median, because median here it is very close to a 0, correct? So that's what you should draw a conclusion whenever you have right skewed or left skewed data. Okay, so this graph will clearly tell. We will see with the help of formula, also with the help of skew. Okay, so there is some function called skew which will give the exactly skewness. So basically skewness lies between -5 to +5 if your given data is following Gaussian normal distribution. Okay, it may change the value based on left skewed and right skewed. So -5 to 5 if it is coming, means it is following the Gaussian normal distribution, because 50% data lies exactly from symmetric line exactly at the left side and exactly at the right side, another 50% data. Okay, so that's about your skewness or symmetric of data. So let me just show how we can visualize using Python. So as usual, Python, I'm importing NumPy, Panda, Matplotlib, Seaborn, and there are two extra libraries which will help us to generate skewed data. Okay, there are other ways also, but there is direct function. With the help of function, let's generate and plot it. So SciPy stats. So if you guys are using Anaconda, definitely SciPy will be installed. Under that, we have stats library. In this library, we have something called skew normal. So from normal distribution, it will create skew data, and we will do the KD plot for that. And using statistical library, you can just calculate mean, mode also. Like direct functions are there, because in NumPy you may find mean and median, but mode is not there, right? So I think this is the library to get all the data properly. So let's see symmetric distribution. So what I'll do, I'll take another variable a here and form np dot random dot normal distribution. Okay, from this function I'm going to generate the data. So what and all parameter it takes? So as Gaussian normal distribution, location means your mean, where exactly it is located at 0th location. Okay, and scale is nothing but your variance or standard deviation. So by default normal distribution, this is set. If you guys want, you can change it. And I'm just going to use size equal to, let's say 500 points. Okay, and if I just do sns.kd plot a, it is going to show me the KD plot or distribution plot, right? So this is what I showed, right? If you take a look at the Gaussian normal distribution curve, your mean will be exactly at 0, mean equal to 0. And that's what you see here. Your peak, wherever exactly lying, right? The mean, median, mode, all will be lying in the 0th position. Okay. Now let's talk about the skewness, how we can get the data. So what it tells basically in statistics, skewness is a degree of asymmetry observed in a probability distribution, because whatever curve you see, right, we have already talked about PDF, right, probability distribution function. Okay, so probability of getting this number, what is the probability, right? So it is basically 15%. Getting 0 probability, what is the probability here? Close to 35. Okay, so this is PDF function. So what it tells in statistics, skewness is a degree of asymmetry observed in a probability distribution that deviates from the asymmetrical normal distribution. And that is nothing but a bell curve in a given data. So let's see how to generate. We have already seen in the whiteboard, like we have negative skewed and positive skewed. Okay, so how we can generate? So let's generate negative skewed data. So we have skew norm. I just take another variable here, let's say s equal to skew now dot, we have random variable sample here RVS, and under this it takes argument, right? So one argument is like, what is the skewness you want? Let's say skewness, I'm just giving some value. Let's say since we are going to give negative skew, right, I'll just give -2. Okay, and here your LOC is nothing but your location. Then let's say I'm going to give location as 0, and scale I'll give, let's say, 1. Okay, and what is the size? Equal to, let's say, 500. Okay, and let's go ahead and print it. So if you just see here, it is going to generate that data which is little negatively skewed. Okay, so how to see that? By looking at the value, you will not notice whether it is really negative skewed or positive skewed. Okay, so better you just do the plotting. So how can plot? sns.kd plot and use s. You see here. So negative skewed means left side. If you want to make it little bigger, right? So it will just show the value much better. Maybe I'll take one more sample here. 1000 samples plot. Okay. So you see your mean is lying somewhere. Sorry, mode is lying somewhere in the this peak, right? That is nothing but 0 because we have given location equal to 0, scale equal to 1. That is standard deviation. Total size is 1000, and your symmetric data somewhere here, and your median will be somewhere here, and mean will be somewhere here. Okay. Now same way we can just generate positive skew data, which will be nothing but right side. So for this I can just give, let's say, 5. You see here in the right side, this is basically right tail value, correct? So tail will be a little bigger on the right side. So here your mode is here, and mean will be somewhere here, and this is your median. Okay, that's how you generate. This is just for visualization, but mostly you will be getting the data from third party, or maybe you download it from internet. Just do the KD plot, and by looking at the KD plot, you can say whether it is left skewed data or right skewed data or positively skewed data or negatively skewed data. Okay, so that's about this. Now let's talk about another parameter called kurtosis. What is kurtosis? So kurtosis is nothing but whatever peakness of the data, whatever peak you see, right? This is called kurtosis. There is a formula. I'm not going into that formula level, but you just remember, if more the data, if more the peak is, means more number of outliers are there. Let's say kurtosis is represented as k. Okay, so if k is more, means chances of having more outliers. So it not only tells about outliers, but it also tells, let's say this is the mean, that's at 0, right? So whatever width you see, right, this also talks about how your data is spread from mean. Okay, if less is spread, or maybe width is little more, means there's not large number of variation in the data set. Okay, because all the data is lying somewhere near to this median, because the central tendency or central limit theorem, what it is, right, whatever mu you have got or median you got, right, all your data is just lying somewhere near to this mean. Okay, so lesser the spread, or sorry, lesser the width, means your spread is less or variance is less. That's why, so when I say variance, means, right, if more variance is there in the data, let's say your mu is here, and let's say first variance is here. Okay, so automatically you'll see your peak is here, and exactly you'll see this kind of curve. Your witness will be more. Witness is more, means variance is little high. It is super high. Okay, so similarly, if I plot little variance or variance on variations on this particular kurtosis part, so let's say we are having very high peak, and there's another graph very less peak, and there's another graph this kind of peak. Okay, so let me take another color and just show you guys. So here spread is less, means your variance will be less. Okay, because all the data will be centered on mean. Now here, if you see, your variance will be high because spread is more. Spread is more. So variance is high. Here you see too much spread, right? Its width is very high. So spread is also very high. So just by looking at this KD plot, right, you see just the witness of that particular 2 lines of that particular curve, right? It is going to tell exactly. That's what this graph talks about. How's your spread or how much variance is there. Okay, so spread is super high, I'll mention. Hence variance is also high. Okay, so peakness is always tells about how, I mean, more number of outliers will be there, that is one thing. And it is going to tell like how spread is your data set. Okay, so width is less means less spread, or variance will be less, and width is very high, your variance will be high. Spread is very big in the data. Okay, that's what will be told by kurtosis. So higher the value, so you can see this value will be higher, and here the value will be less. Okay, so we can always see the data by, so I don't have any direct function to generate some data where high kurtosis, less kurtosis, but I can just plot them by with the help of manipulating the bandwidth of the KD plot, because it is all telling about the bandwidth only, right? How much bandwidth is there, all those things. So let me just go ahead and create the data. So let's say I have np dot random dot randint. Let's say 1 to 100, I'm generating 300 value. 500, I'm generating 300 value. Okay, let's go ahead and do the SNS dot KD plot A. Okay, so let's say this is your data, and now there is one parameter called bandwidth. Adjust. If you just give, let's say I'm just giving bandwidth 1, so what will happen in this case? Okay, this is same. I'm just going to comment it, and this I'll give 3. You see here, as you go with higher bandwidth, your curve will be very smooth and spread will be more. You see here. So here I'll just mention label. Maybe for timing, I'll just mention kurtosis. Okay, so that you can correlate this data. Kurtosis equal to, let's say here it is 1. So that you can correlate 3, and here it is 6. PLT dot legend PLT dot show. Okay, so you see here. Okay, I could have given in a different way. Here, this is not the kurtosis. Basically, kurtosis will be different. Okay, here we are just giving bandwidth. This should be bandwidth, not the kurtosis, because higher the kurtosis means less the variance. Okay, so bandwidth 1 means high kurtosis. This will give fair idea about this. High, low kurtosis. Okay, so 6 you see here, it is more flattened curve, right? So here kurtosis will be low. Okay, so that's what I want to show. So you guys should understand, whenever you plot any kind of KD plot, right, you just take a look at whether it is left skewed or right skewed, how much is how peakiness is that graph. More the peak, higher the kurtosis, more number of outliers will be there, and spread will be less, variance will be less. Okay, so that's what I wanted to show you guys. I hope you understood this symmetric distribution, skewness, what is left skewed, positive skewed, or right skewed, and what is kurtosis, what is the meaning of it. Okay, so whenever you do inferential statistics, right, you will be doing a lot of data visualization. So just by visualizing, you will get to know a lot of insights about the data just by looking at the graph. Okay, and one more thing I wanted to show here, how to calculate this skewness or kurtosis, right? So let's say you have given a data. I'm going to generate one small data frame. So let's say a equal to np dot this direct function for that random dot rand int. So what I can use here, yeah. So let's say 1 to 400. I'm generating 100 data, and I'm going to create a data frame with one column, because that function you can apply on the data frame only, whatever skewness or kurtosis is there. So pd dot data frame of a, and let's visualize data frame. Okay, this is your data frame. I want to calculate kurtosis and skewness of this data. So first let's go ahead and plot it. So df 0 dot plot kind equal to kd. It is going to be normal distribution only, right? Because we have taken from normal function. Okay, so that's this. And now you would like to calculate what is my skewness. So df dot, we have one function called skew. It is going to return what is skew. So this is positive skew, right? Why positive skew? Because you see this tail, right? It is more spread or more tailed around right side. That's why you see positive skew. Okay. So without plotting also, if I would have given a skew function, it would have written some value, right? By looking at the value only, I would tell, okay, your graph is going to look like this, or graph is going to look like this. Okay, and what is the kurtosis? So both functions are same here. It is -1, right? So because it is more towards flat, it is not so peaky. So if you have any graph or you have data where peak will be too much, then you will see some positive values. Okay, so that's how you calculate the skew and kurtosis. Okay, guys, so that's all about symmetric distribution. And if you haven't understood something, then please leave out the comment in the comment box. I'll help you guys in the next video. Okay, and those who have not subscribed my channel, please do subscribe. If you would like to see some feature video if on some topic, please give some suggestion. I'm definitely going to make video on that. Okay, guys, thank you so much. Bye bye. See you in the next video.